Golden Eagles. Welcome to the 52nd episode of The Knowledge Nest. Today is February 12th. This episode is going to air on Valentine's Day, and we are all going to talk about something that we are all loving, or I hope we are, generative AI and neural networks and how exactly they work. A lot of my work has been, even with OER and the other aspects of my work, has been bleeding into artificial intelligence. And so I thought I would take a minute and talk about exactly how these machines work, these tools, and how that should impact what we think about them and how that impacts information literacy. I've talked about treating the outputs with some skepticism, but we are going to talk about how they make what they make so we can understand why we should be so skeptical about them. Plus, we have a lot of Valentine's Day cards in the library and Valentine's Day activities we would like you to do. So please drop by the library and spread the love and spread the appreciation for staff members, your friends, your peers, your family, whoever you think needs a little pick-me-up around this time, whether it be for Valentine's Day or it just be for February and it's cold and it's the end of winter and people are being, some sad or whatever reason people need to pick me up, or if they don't, if they just want to show someone that you love them and you care about them and are thinking about them, come and do a Valentine's Day activity. We have our book club in a few weeks that is going to be talking about Black History Month. February is Black History Month. We have a wonderful display on that in the front of the library, so please come and look at those books, check them out if you want to. We're going to be talking about that near the end of the month. Now, for our topic this week, how generative AI tools work, and then we're also going to be talking about specifically large language models. So generative AI, the vast majority of generative AI tools, are what are called neural networks. They're a bunch of computers that use code, calculus, and essentially context of data to determine what it should generate for you. It can't read your mind. It can't give the concepts. It's not thinking, it's computing. So neural networks are essentially chains of computers or computing stations. They take data from one station that gives it to them, and then they push it out toward another. And essentially, they're processing this data, they're applying functions to it, they're applying different multiplications and additions, and they're sending it to the next station or the next node in the network, in the chain. And so here we have a public domain image. We have the input layer, and this is where you put your text, your prompt, and then something goes from that layer, or possibly can go, to each of these nodes. And then they apply their own functions to this. And it goes on, which are what these ellipses are for. And it may have, 2 or 3, or no, it could just go from here to here. But any number of intermediary layers, and then it comes to the end layer, where it's finally we have our last multiplications or additions, and then it comes to the output, 1 or 2 output nodes, and then we see what it comes out with. And so, again, a lot of computations, but not really thinking. The context is in the data. Each layer or node processes the data from the station before it and possibly passes it on to other stations. And they're essentially trained through data-filled calculus. How exactly does this work? Well, let's say you have an image. And every image on the computer is made up of pixels. Well, you have, let's say, if you're really having a really low resolution image, a ear or a light brown tile, a light brown pixel would be in the place of an ear. Okay? And so we'll have this ear be the part, a data point that goes through the input layer. And then when it comes to the inner layer, it says, oh, that ear, that brown part, typically ears are connected to cheeks and faces, and they're typically about 3/4 of the way up in a photo. And so we're going to put it 3/4 of the way up in a photo, and next to the ear, we have the cheek and we have some sky. And so we're going to have sky and cheek, and then we're going to have a face. That's a really rough translation of what happens, or example of what happens, but essentially with images, that's what happens. When this occurs in images, it's called diffusion. When it occurs in text, it's called transforming or transformers. And a type of transformer is called a large language model. And so I got this diagram. This is available under a Creative Commons Share Alike license, attribution Share Alike. And so here are the generative models, and they're a subset of neural networks. And then the large language models are a subset of that. We have, the diffusion would be one, and then the large language would be another. And so this also explains why when you try to put text in an image in a generative AI image creator, that doesn't really work the best, because it treats the text as an image, not as a textual data set, not as a TXT file or whatever it separates it into. And so that's why you have issues with that. Ideogram.ai has kind of solved that, but there's still some issues, but that's why text doesn't really work with generative AI creators in general. And it's getting better at that. So large language models, again, are a subset of these neural networks. They take the data, they apply a bunch of calculus to it, and it comes out with an output. The data passed through the network is text or parts of text, letters, or even parts of letters. The processes of basic generative AI are added to with contextual and grammar processes. So we talked about how the ear was part of a face, and it's next to the sky, and it's about 3/4 of the way up. Well, let's take this sentence. The data is passed through the network is text. This is a very specific sentence. And so we're going to say that passed and through are two data sets. Well, passed in this tense doesn't really make much sense when it's by itself, but when you have it by data, when you have it by through, and when you have it by the object of the preposition, the network, it makes sense. And so the large language model is going to interpret passed in the context of the data, the through, and the network. And so it essentially doesn't track sentence fragments. It doesn't track syntax. It only tracks the context of that syntax. Essentially, it's modeling what it creates off of what it has created in the past, user responses to that, and what the syntax and grammar have been in documents, conversations, and other samples that have been given to it. This is why it's essentially giving what you want. It gives you what it thinks you want. And so it shouldn't be recognized as an accurate purveyor of truth or of accurate information. It's giving you literally what it thinks you want. It's saying this is what has been given in the past. This is what people have liked in the past. Again, this is a very rudimentary analysis. And so therefore, this is what I'm going to tell people. This is what I'm going to give as an output when these things are asked for. And so if you see in this, we already went over what ChatGPT is, but in this image, this is one of my conversations. I have headings. I have these hashtags or these pound signs as headers for context, role, objective, style, because you need to separate these things. And then I tell it exactly, specifically what I want to do, the role I want it to take, why it's doing it, the context, and even the style, the professional tone and active voice, because it needs to be directed in all of those. And so I hope that this kind of helped you understand what exactly large language models are, neural networks, and how that kind of affects the workings of ChatGPT and some other text tools, and a little bit about some image tools. And so thank you for watching this episode, and I will see you next week here on the Knowledge